Now let's consider an example of the quotient rule. So my example is find d by dx of the derivative of sine x over x. Alright? In order to solve this derivative, what I'm going to do, I'm going to use the quotient rule. So I will write d by dx of sine x over x is equal to, if you remember, the quotient rule has the denominator is the square. So basically in quotient rule we square the denominator, and at the numerator we write denominator times d by dx of numerator, right, minus numerator times d by dx of denominator, which is x, right? Now let's simplify further, and if we do that, I will write as x squared x times d by dx of sine x is cosine x minus sine x, and then d by dx of x is 1, right? Now let's simplify further, and if we do that, we will get this one as x times cosine is x cosine x minus sine x times 1 is sine x over x squared. So as you can see, d by dx of sine x over x is equal to x cosine x minus sine x over x squared. And this is basically the derivative of this function. Now, let's consider another example. So my another example is find the derivative of d by dx of 1 minus cosine x over sine x, right? Now again, as you can see, I have a numerator over denominator, so I am going to use my quotient rule. So if you remember, my quotient rule was a square of the denominator, which is what, sine x whole square, and then at the numerator I will write denominator times d by dx of numerator, which is 1 minus cosine x, minus 1 minus my numerator, which is 1 minus cosine x, times differentiation of denominator, which is sine x, right? Now let's simplify further, and if we simplify, we will write this is equal to, my denominator is basically sine x whole square, right? And my numerator is sine x times d by dx of 1 minus cosine x. So if I want to differentiate, I need to distribute d by dx inside the bracket. So if I distribute, I will find d by dx of 1, which is a constant. So the d by dx of constant is 0, right? And then I have a minus sign. D by dx of cosine x, which is what? Negative sine x, right? This is my first derivative right here, my first term, minus 1 minus cosine x times d by dx of sine x is cosine x, right? Now let's simplify further, and if I do that, I will write this one as sine squared x at the denominator, and at the numerator I have sine x, so I will write sine x times 0, and then minus times minus is positive, so I will write plus sine x, right, minus, I have 1 minus cosine x times cosine x, so what I'm going to do, I'm going to distribute this cosine x inside the bracket, so I'll write cosine x times 1 is cosine x, and then minus, this minus sign right here, cosine times cosine is cosine squared x, right? Now let's simplify further, and if I do that, I will write this one as sine squared x, this is my denominator, and at the numerator I have 0 plus sine x, and 0 plus sine x is basically what? Sine x, so I will write sine x times sine x, right, minus this minus sign, and then I have cosine minus cosine x inside the bracket, so I'm going to distribute this negative sign inside, and if I distribute, I will write negative times cosine is cosine x, and then negative times negative is positive, and then I have cosine squared x, right? Now let's simplify further, and if I do that, I will write this is equal to my denominator, which is sine squared x, right? And then sine times sine is sine squared x, right? Minus cosine x plus cosine squared x. I'm going to rearrange my differentiation, and if I do that, I will write this is equal to, I have sine squared x at the denominator, and at the numerator I have sine squared x, and I'm going to write this sine squared x and this cosine squared x together, so I will write sine squared x plus cosine squared x, right, minus this cosine x, right? If you remember from trigonometry, we have sine squared x plus cosine squared x is equal to 1. So what I'm going to do, I'm going to replace sine squared x plus cosine squared x is equal to 1, and then if I replace, I will write this is equal to, this is 1, so I will write 1 minus cosine x over sine squared x, right? So as you can see, the differentiation of this function is basically equal to 1 minus cosine x over sine squared x. And this is how we will use the quotient rule to find the differentiation of given functions.